Hey everyone, I forgot to update the problem name. I will do it later. Oh, nice. Today problem is the 1000th one. Minimum cost to merge stones. And setting the timer. Go. I just have less than, almost 30 minutes today. So let me see what I can do in 25-ish. Signature. Fortunately, it's not a big one. And piles of stones ranged in a row. Stones, which is a list of integer. A move consists of merging exactly k consecutive piles into one pile, and the cost of this move is equal to the total number of stones in these k piles. Total number of stones in these k piles. Return the minimum cost to merge all piles of stones into one pile. If that is impossible, return -1. I'm guessing we are also given k as an integer, and we need to return them in another integer. What I don't understand yet is how it can be impossible of merging exactly k consecutive piles into one pile. Oh yeah, I see. Maybe. I think I see, so let me write some tests. So first of all, let's say that we have 1, 2, 3, 4 as our stones, and the k is equal 3. I think this is -1, just because, for example, let's say we merge first the smallest stones, which sounds like a reasonable greedy approach. That probably won't work, obviously, but still. So we merge first the first 3, so it becomes 6 and 4, and then we need to merge 6 and 4, and we have to merge exactly k piles. So whether we can or cannot can be calculated. So let me call this out as a challenge. So can we even do that? Probably arithmetics. And then the next question becomes, okay, which piles should we merge first? Because that would impact other choices that we are making. Like any pile that we are creating will increase the number of stones. Yeah, so we should be targeting the smallest possible piles and merging those smallest possible piles the least amount of times. So there is actually a predefined number of times, the predefined number of merges that we will have to make. So let me abstract this away a little bit. So we have some number of piles, and we have some merges that we need to do. So what does it mean for us? There are actually few places where we can choose those merges. So here I'm choosing merges for like three stones. So let's assume that we can merge 3 stones, merge by piles of 3. So how do we ensure that? So we are removing, every time we are removing solution. Can we do that? every move, we remove k minus 1 piles. So if okay, do we have n? No, I don't think we have n. Let's say that n equals the length of stones. So if n minus 1 divided like mod k minus 1 equal to 0, possible. Otherwise, we can just return -1. So it basically means that we will be removing 2 stones at a time, and after n such operations, we will have one stone, sorry, k piles at a time, k minus 1 piles at a time, and then by the end of these moves, we will have just one pile. So this is possible, and we also can figure out how many moves do we need to make to achieve that. So then what it means is that for every stone, we will have between what if it's just one stone? So there is for one pile. So let's just say that there is in each case 1 and k equal 5. Then the minimum cost will be 0, right? Because we don't have to make any moves, even though we cannot possibly make even one move. We don't care, we have like 0 cost, right? So back to what I was saying. So otherwise, in all the other cases, if we have a possibility to merge piles, we'll have each stone will be merged between 1 and m times. So let's say that m will be equal this. It's number of moves. So then each stone has between 1 and m merges that it participates in. And the thing is that if a specific sequence of, we are only operating in sequences, right? So how do we approach this problem? I feel there is some like dynamic programming aspect here, because we can like store, what if we have already like the sequence of compacted stones that we have? How do we represent this to memorize? I see there is a message. Hello. Yeah. Hello, back to you. Okay, so how do we store the state? So the state in this problem will be like a sequence of INJs. Let me actually call this I1, J1, and then I2, J2, etc. So what I mean here is that we first choose to compact some group of stones, and then we have compacted those, and then within these two elements we will have a particular sum, and we will then be adding this every time then we are like adding merging new piles. Okay, let's since I cannot figure out a proper approach, let's first discuss brute force one, right? So for brute force approach, what we will need to do, we will need to try n minus k options, for the first, merge n minus k minus 1 for the second, and then up to n minus k minus m, or minus m plus 1, but essentially, like, if we are discussing the order of magnitude, it will be on this order. So that is n minus k times m. Operations in total, like considerations, but then we will also need to figure out, like, okay, so here for each of those possible choices, oh no, we just start that, so it's not times m, right? We are multiplying all of those, so it's n minus k to the power of n. So it's exponential. If we treat it at face value. But is it really exponential? Can we try to like, simplify the state in the way that I have mentioned here? The thing is that if we are let's say we want to calculate sum between two numbers in these piles, in the stones, we can calculate this with prefix sum in of 1. That's why I'm not also multiplying it by the fact that we will need to create the sums. Well, yeah, there will be some repeating states. So if for each of the states we store it like this and calculate the final result, like the result of what's the minimum number, minimum cost that we can get from this. So we basically go over all the possible starts. Then we will need to cleverly modify the structure to store the state. And we will have, how many states we will have? Let's also discuss that. Of n minus k squared, because of all the possible individual elements that we can have, and we can also have up to n minus k divided by k of those. Yeah, basically times n divided by k space, which sounds like it can work. And then if we keep those sorted in the sorted order, it can be n of k, n divided by k operations on each update. Because that's the biggest possible number of tuples, subtuples in this state. Well, yes, it can work as a kind of like dynamic programming problem with memorization. And in this scenario, so if we do dynamic programming, it will be, I think, n minus k times n. Because for each of the state, for each of the states, we'll calculate things just once. So it will be at most not this, but k squared times n divided by k runtime, because we need to calculate it for each of the states. But it's reasonable overall, depending on what's the total number of stones that we can have. So yeah, we actually don't have that many stones and that big of a k and that big of an n, so this solution might work. Let me do the implementation in whatever time I have left, like 10 minutes. Let me try. Okay. Yeah, we will need to copy this copy the state each time before passing to the next level, but fine. Okay, so what we will be doing, we will be doing DFS with memorization. And our DFS will take the state, which will be a tuple of integers. And it will be returning an integer. But first, we will figure out if the whole thing is possible. So let's define n as length of stones and return -1. So now this is impossible. Otherwise, it is possible, and then we can run our function. So we will also need to calculate prefix sum. Fix sum either way, so sum is 0, prefix sum is this, and then for piling stones, if not if, just current sum. Oh, yeah. Perfect sum equals 0. We start with 0. And we need to be able to calculate perfect sum even for like individual elements. So this is important. Current sum Okay, 20 minutes have passed. We have 10 more before I have to drop. Okay, current sum plus or equals to pile and prefix sum and current sum. Okay, so now we have prefix sum. And what we will be doing here, we will be calling result equals DFS of state which is empty state. Is it? Let's just call it like this, just so that we can ensure that it works. And return result. So we are just passing an empty state here. Now we need to figure out how to process all this stuff inside. Ideally without doing key operations, or we can ignore that. Do we want to just merge those and don't bother? Because these things can be at most 100 stones, right? So we can just store the state as our merged array. I'm thinking about what's the nicest way to store this, but it's clunky, and it's easier just to apply the same function again and again and again. Yeah, often function, so there will be often steps in each, but often divided by k is similar to often at worst. Let's just have it as a tuple of integers. This is easier to implement. And I think it should bring us to the same kind of result. Okay, so now what we do. We don't need prefix sum in this case. I will not be removing this. Let me choose Python, just so that you can do this. No, I cannot. I cannot comment this out. Why? Okay, I can, but it doesn't always work, right? Okay. Let's use plain text. I will just cut it and paste it here. For now, I will be doing what? I will be doing things manually. Okay, for end in state, and I need also none in state enumerated. Current sum equals 0. So I'm always adding the number to this current sum. Current sum plus or equals to 0. And let's call it also, let's call it R and L equals 0. So current sum equals to current sum plus or equal to none, obviously. Then if R bigger or equal to k, so if R is equal to k minus 1, right? Yeah, because k is the total number of elements, so let's say we have 3 elements, and 0, 1, 2. No, when R will be equal to 2, which is k minus 1, we will already need to update our situation. So now we need to do what? We do new state will be equal to I actually don't know how this works with tuples. Do I still first need to translate those into lists? But my idea will still be the same. Let's assume the tuples work this way. So basically tuple up to L, non-inclusive, plus current sum, plus tuple starting at L, R plus 1. So if we have to, we can pass those as to lists. Okay, let's just assume that tuples don't do that. Only lists can do that. Okay, this is new state. So and min post will be float of infinity. The new state is this, and state result will be we are calling the same function differs, but we need to call it a tuple from new state, and we do this, and if actually min post is equal minimum of min post and current sum plus state result. And then we need to remove our leftmost element so that on the next loop we are fine. And how do we do that? We just do current sum minus equals state L plus equals 1. Return min cost. Okay. Is this it? This might be it. This probably will not work, but I don't have more time to check today, unfortunately, so I will just need to drop off. Like right now, I just have one chance to try to run it. Come on. What are these networking issues? Okay. Output null, output -1, output null. So why is it output null? Oh yeah, just because I should be passing stones here. Come on, network error, reload this, and I see another message, and let me respond, hi, back to you. Hashable type list, okay, tuple, stones, unsupported type, current sum equals 0 for num enumerate. Okay, this is strange. I have no idea what's going on here. Type generic alias. I have messed something up. I don't know what. I don't have time to uncover this, but I will try to do it offline. And thanks everyone who was watching me today.